So it's come to my attention that I forgot to work with one of my numbers with the first activity I did in the last video. So instead of redoing that activity all over, I am going to just pretend that that 66 never existed. If you want to do it again with 66 as a part of your work, feel free. I want to show you instead how you could work with a larger set of data in order to make a box and whisker plot. So with this, you might be able to easily see the minimum, the median, and the maximum in Q1 and Q3. That's fine. Go ahead and put those down if you see them. 140 is the smallest number, 460 is the largest number. Then you're like, well, what about that middle number? It's in order from least to greatest. So the middle, this number and this number here share the middle. So what number is exactly in between 305 and 310? Maybe you don't want to figure that out. That's okay. Let me show you how you might be able to determine this. What I'm going to show you now is how to take a data set that's been entered into a spreadsheet and find the min, the median of it. So in order to find the min, you say equals and start writing min, and you'll see minimum shows up. It says the minimum value in a numerical data set. Click it, and then you'll select the entire data set, and it will find the smallest number in that data set. We already knew it was 140. Yep, still 140. I'll show you that again for max. Equals max. Select it, and then select the entire data set, and it will find the maximum, even if it weren't in order. Median equals median. Okay, and then we'll select again the entire data set, pressing enter. Q1 is the median of the top half, so we'll do median again. Median, and I'm going to just select the top half of the data set. And that is 255, and then we'll do median of the lower half. And that is 347.5. And those are the 5 numbers we would need for a box and whisker chart. Now, you could have found the quartile and not done the median of the upper half. So let's do that. Quartile, select all of the numbers, enter, and then we're going to put a comma, and it says I need to have the quartile number. We're in quartile 3. Quartile 3. There you go. And you'll notice that this number was slightly different than the median number that we had found. So if I do the median of the top half, you'll see that those are slightly different numbers. And the easiest way for me to explain that is there's different ways to make a box and whisker chart. And for us, the way that I'm teaching you in our class is not the only way to break the data up into 4 groups of the same size. So depending on what technology you use, you will get slightly different answers, and depending on what class you're in. So for us, and in this class, we're going to do the method that I've described, which is finding that middle number. So the middle number is the 347.5. So be careful using that quartile. All right, so let's take these numbers back on over to our work. The median was 307.5. Quartile 1 was 255, and quartile 3 was 347.5. Now let's make a scale. I'm going to go on up to 500. So 200, 300, 400, 500. And then our first number was 140, labeled above, 255, 07.5, 47.5, 460. Line going through it all, and a box around the middle. Not too bad. We can define any percentile as the data value with that percentage of values below it. For example, the median is the 50th percentile because half the values are below the median, and the third quartile is the 75th percentile because 75% of the data values fall below that third number. Percentiles are used when comparing lots of things. Test scores, when you take the SAT or the ACT, they'll be used there. They are used to compare the growth of children when they're young, and the results are given to you such that if you were in the 83rd percentile, for instance, that would mean that you scored higher than 83% of the people who took the test. So if you were in, let's say, the 50th percentile, that would mean you were right in the middle. Half the people did better than you, and half the people did worse than you. Activity 4, we're going to compare populations. The box plots of service times for 2 fast food restaurants are shown below. Compare the length of time to get served at the 2 restaurants. What you want to remember is from the min to quartile 1 is 25%. From the min past quartile 1 to the median is 50%. If we're going to go past the median to quartile 3, we have 75%. And if we've got everything, we've gone from the min to the max, we've got it all. We've got 100%. So we can see in the 2 box plots that store 2's median service time is what? I want you to put in the median service times of store 1 and store 2. The median, again, is that middle number. The blank percentiles are 2.9 and 5.7 minutes. 2.9 is that third quartile number, and so is the 5.7. So how many or what percentage of the customers have been served at that point? And it is the 75th percentile, so that means that store 1 has served 75% of the customers, and store 2 has served 75% of their customers within 5.7 minutes. Which store would you go to if you were in a hurry? That is for you to decide. I would like your rationale as to why you're going to store 1 or store 2 using some measure of spread. So talking about the range of data or the percentiles or how quickly you would be getting served. So let's consider these 3 sets of quiz scores. Find the mean and the median for each. Not too difficult. They're all a bunch of 5s. So the median would be 5. The middle 5 would be a 5. Next one, 0 and 10 share the middle, so the median again would be 5. If I add all of these numbers up, I'm going to get 50, and 50 divided by 10 is 5. Next one, median 5, median 5. Mean and median are both 5. All of them are 5, so obviously these sets of data are all the same. So how are they different? They're different because their spreads are different. And spreads are range, and we'll get a new one here in a minute, and that'll be standard deviation. So the range for section A has a range of 0. For section B, the range was 10, the largest range, so the most varied. And for section C, we had a range of 2. Another measure of spread is standard deviation. Is a measure of variation that tells us how far on average the data values deviate or are different from the mean. And it is determined by taking the square root of the sum of the squared deviations from the mean and dividing that by n minus 1. So that was the language for this equation below. And I'm going to show you this equation. It's more of a process that you'll be going through. I think you'll be fine. It looks a little intimidating, but we got it. In order to do it, we'll need to follow these steps. We'll need to first find the mean of this set of data. So in order to find the mean, you'll add all the data values up and divide it by 10. Add them all up, divide by 10, and you'll find the mean. That is your X bar number. You'll find that out. It will be 5. Then we'll find the deviation. How far is each data value away from the mean? How far is 0 away from the mean? It is 5 away from the mean. 0 minus 5. Now technically you could write -5. It's not going to matter here in a minute though, so if you just wrote 5, you're okay, because we're going to square it. Anyway, next one will be 2 minus 5, which is -3, or you could write 3, it's fine. Then we'll have 3 again. How far is 5 away from 5? It is not very far at all away from 5. 0. How far is 8 away from 5? 3. How far is 10 away from 5? It is 5 away from 5. We have just done this most inner part. Now we have to square it and then sum it. So squaring is just taking those numbers and multiplying by them by each other, and then that sigma symbol means sum, add them all up. So we'll take -5 and square it, which is 25. Like I said, it didn't matter about that negative because a negative times a negative ends up being a positive. We'll take the -3 and we'll square it and we'll get 9. Take that, it's technically a -3, but again, 9. Keep squaring things. All right, then check. Sum the squared deviations. That was this command, sum x minus x bar, and then we squared it. So we've got to add all of these squared deviations up. Basically, we got to add this column up. And my 25 looked a little funny there. Okay, so that looks like 86. Divide by n minus 1. And you might ask yourself, what the heck is n? N represents the number of data values that we had. So n in this case is 10. 10 minus 1. 10 minus 1, 9. We're going to take the 86. We're going to divide by 9. 9.5. Well, I guess I don't have to round. I could put a line over it. Make that an equal sign. Then we will take the square root of that number. Now I'm definitely rounding. So standard deviation is equal to 3.0912. And we're going to take things out to the 4th decimal place in this class. That is the standard deviation. And you might wonder what the standard deviation means. And it is basically saying that if you go 3 or so units away from the average, which in this case was 5, you should capture or get majority of your data. And technically, you'll get into this more when you are in a statistics class. You'll capture approximately 68% of your data, and this has a lot to do with a thing called bell curves and the empirical rule, which is a little bit outside of our class. I want you to practice that one more time. I want you to find the standard deviation for a set of values, and this happens to be a set of peanut butter prices. Find the deviation, which is just the difference between the mean and the data value. Square that number. You'll get that in this last column. Add them all up. Divide by n minus 1, and then be careful with your n. You have 1, 2, 3, 4, 5 data values, so you'll divide by 4. And then take the square root. that is the process. I want to see if you can practice that process. You'll see here that data set from before come back to haunt us, which is a good haunting, trust me, because that process was painful and there is an easier way to do it, and so I will show you that easier way. Go back to that spreadsheet that I know you opened and used earlier. You can easily find the standard deviation. All you do, I'm going to label it standard deviation. I'll say equals, start to write standard deviation. Oh, it pops up. Don't write too much. ST, select standard deviation. Actually, what I want to do is I want to select standard deviation of a sample, which is going to be standard deviation.s. And we're working with a sample, meaning not the entire population. So standard deviation.s, there you go. The standard deviation of that data set was 78.67. Well, we'll have to round that on up to 8. And 78.68. Deviation is about 78.68. And we were in dollars, so I should keep my units. So that was a lot easier than the process that you'd been practicing before. So consider that. The last thing that we're going to discuss in this class will be z-score. The z-score of a data value is the number of standard deviations it is away from the mean. And what you'll do here is you'll take the data value, you'll figure out how far that data value is away from the mean, and you simply subtract those two and divide it by the standard deviation. If you end up with a negative number, it means that it's smaller than the mean, and if you end up with a positive number, it would be larger than the mean or above. Z-scores are to determine the relative unusualness or weirdness of a data value with respect to its own distribution. Anything further than 2 standard deviations away is considered unusual. I'm going to do activity 9 and leave activity 10 for you. The oranges at a local grocery store have a mean of 5.8 and a standard deviation of 1.2. Great. So that gives me 2 parts of my formula. So my z-score, they just gave me the standard deviations, that goes on into the denominator, and they gave me the mean. Then they're going to tell me the apples, and this is all for oranges, so I should probably label that so I don't get confused. Oranges. All right, and then we have apples. Apples have this z-score going on. They have a mean diameter of 4.2 and a standard deviation of 0.6. All right, so I used those. Okay, Allie closed her eyes and selected an apple and an orange. When they looked at both pieces of fruit, they seemed small. If the orange had a diameter of 4.2 and the apple had a diameter of 3.5, which one was smaller relative to the respective piles of fruit? Well, let's see. The orange, so I'm going to put it in the orange, was 4.2. And then we got the apple was 3.5. Make sure if you're using technology that you wrap your numerator in parentheses. And I'm seeing that my orange has a z-score of negative, so it is small, meaning that it's below the mean of 1 1/3. And the apple, 3.5 minus 2.4 divided by 0.6, had a z-score of negative, also, so still small, 1.16, repeating. So which one was more weird? Well, this z-score is further away from 0, so the orange was more weird. I'll say more unusually small. So you're going to try number 10, the mean weight of men, and find the z-score of that. Today we focused on measures of spread. Hopefully that helps round out all of statistics for you. We talked about graphing, measures of center, misleading graphs, and today we talked about how you can measure how spread things are and then compare different items or people based on their z-scores and standard deviations. I'll see you in class.